Question 8 is to find the velocity and acceleration for the given position. Here you can see we have been given the position s of t, and we have to find the velocity and acceleration. So I will do the manual method using the power rules because this is a very important method. No matter what, you have to learn this. And the calculator method would be much more complicated than directly solving it up. So what do we do is, you just remember when we derive derivation prime of s dash. See, if I derive, it's going to be s prime of t, right? This is the velocity. Derivation of position is velocity. Let's derive it. This 2 comes down to be minus 32t to the power 1 plus t to the power 1 is 0. So it'll be, it's 1. T to the power 1 is 1. So we get 40. And over here, it's t to the power 0. There's nothing. So it's basically 0 constant, 0. Now that is the velocity. That's it. What about the acceleration? They have not mentioned at any specific time interval, so you just leave it like this. Okay, you can omit the last part, that is 0, so nothing over there. What about this acceleration? Acceleration is double derivative of s. Sorry, this should be s, that's the position, double derivative. Or it is the single derivative of the velocity. So basically, we'll derive this velocity, you'll get acceleration. Minus 32 derivative will be minus 32 only, and this will be 0. So that's the answer. That's it. You have to derive the given position twice. For velocity, it's once. This is velocity. It'll be minus 9.8 times t plus 12. And derive it again, it'll be acceleration. It'll be just minus 9.8. So always remember, this is single derivative of the position. This is double derivative of the position, or you can write it as single derivative of the velocity. That's it. What about this? It's a square root. If you remember the formula for square root x, it's 1 by 2 root x. But if you're thinking, how does that happen? I'll just do it over here. So this is basically t to the power half. Square root is radical means half. Plus 2t squared, right? Now, half comes down, the power rule, just apply the same thing. Half comes down, it will be t. Half minus 1 will be negative half, isn't it? Plus this 2 comes down, it will be 4t. But here, let's just rearrange this a little bit, because I know whenever the numerator power is taken down, the power sign changes. So from minus, I can make it positive by just taking it down, plus 4t. Now here what I can do is, instead of writing it t to the power half, I can write it as square root because that's the original form, right? Plus 4t, that's it. And now if you derive this again, what are you going to get? You're going to get acceleration. So this is the velocity. So now this is the answer, yes. But I'll just use this to derive because it's much easier when it's in the power to derive. So this is the velocity, right? For acceleration, I'll just derive this one. Okay. So half is already there and power half. So what happens is, I'll do it in steps. Half multiplied by minus half because this power comes down, and subtract this by 1. Negative 0.5 minus 1 is negative 1.5 or negative 3 by 2. Because you're subtracting and negative numbers, they just add up. Plus 4 times t is gone, it's just 1. So now this is the answer. Now what did I write over here? I have missed the t altogether. It should be written over here, t to the power minus 3 by 2. Now when you multiply this, it's negative 1/4 t to the power. I'll just take that t to the power down to the numerator. So it's t to the power positive 3 by 2 plus 4. And generally, it will be written as 1 by 4. See, whatever is the power, right, will remain. Whatever is 2, that means it's a radical, right? See over here, radical x means x to the power 1 by 2. If we have, say, like this, 4 here, and then over here you have 3. So that would mean x power 3, whatever is over here, you have to write it down. This is 4, 3, 4. That's what it means. So here as well, I'm just writing this radical as over here. If it's only 2, we don't write it. Okay, that's the thing. If it was 3 or 4, we write it over here, whatever the number. And t to the power 3. That will be plus 4. So this would be the final answer for the third question. You can see here Okay, they didn't go in so much depth, but this is also correct because generally in MCQs, right, they don't give it as it is. Like this simple answer wouldn't be there. They will do it in a complicated way. They're going to take it down and write the radicals and everything. So that's why I solved it. But anyways, over here they have just given it in very simple form. And lastly, we have over here in terms of 1 by x, if you remember the formula, it's negative 1 by x squared. How does that happen? Because when you bring the t up, it'll be t to the power minus 1, and then we can solve it up. 10 minus 10 multiplied by minus 1, t to the power minus 2. Now we can just solve it. 10 minus 1 and minus 10 will be plus 10 t to the power negative 2. This is the velocity. Now to find the acceleration, you have to derive this again. It's going to be 10 plus 10 times minus 2 t to the power minus 3. The final answer would be, this is, till over here we have velocity. Now it's all acceleration. So the acceleration would be 10 minus, sorry, this is going to go off. My apologies. What is the derivation of 10? Don't do that in the exam, what I just now did. Very, very wrong. I would have, completely got it wrong. So t becomes, 10 becomes 0. That's dissolved. When you derive a constant, it's 0. So that is not there. It's just this term that's there. So here, this is the question itself. Now from here, okay, this is s of t. I've just taken it up. From here, you can see that's how we rearrange it. And now minus 20 t to the power minus 3 is the answer for acceleration. You can see that's how we write it. And that's how we can easily solve it. Now, even you can check your answers in your calculator. How do you do that is, let's take our calculators first. Let me take this first 21st question, and then we'll solve the others. If you want a single derivative, what we do is shift and dy by dx, isn't it? Now here, negative 16 alpha x squared plus 40x. We can't put t, so we put x here. And then plus 10. Just take any x value. I always go with 1.5 or 2 or 2.5. Don't take 0 or don't take 1. That's the only conditions. And just press equal to. It's negative 8, right? Now, the first derivative is the velocity. If at all you put an x value here of 1.5, you must get minus 8. Let's try that. Minus 32 instead of, you can directly write, 1.5, or you can write it as x plus 40. Don't do the derivative of this. Just calculate x value of 1.5. 1.5. It is minus 8. So only the one which matches gives you the answer. But this particular method is only limited for single derivative. So there is no way you would get the double derivative of acceleration. You will just get the single derivative over here. So this is the thing. And to get the double derivative, you have to know the power rule. So power rule is a must. I'll just show you how we can do it over here as well. See, let's do derivative first of the question. That'll be 10 minus 10 divided by t. And take a value, say x, I'll just take it as 1.5. The value is 4.444 and it goes on. Now here, what is the velocity? We got 10 t squared, but it's minus. So there'll be 4 options. You have to try it for all. Calculate all of them at the same x value which you considered for the derivative, that is 1.5. And you can see here it's 4.444 and it goes on. Whereas all the other options will give you different. Imagine they had another value, say 1 times. And if you calculate it at 1.5, here it's not the same. 0.444, which is completely wrong. And say another question was like this. Calculate at 1.5, other option I mean. It's different. So only one option gives you the correct answer. But it is completely limited only to one single derivative, not the double derivative. So knowing power rules is a must here. And that's the end of the question 8. Very short one. But please remember, the power rules are used for derivative. Calculator can only be limited for a single derivative problem.